Hello and welcome to the lesson which is on prime factorization using factor trees. So you're dealing with prime numbers that happen to be factors, and you're making little things called factor trees. So you might not have used factor trees before, so this might be something new for you. So please keep your calculators away. This is a non-calculator topic. So all you need is a pen, pencil, or something erasable if you like. And your booklets, of course. So, use a factor tree to prime factorize 42. You might have no idea what that means, so I'm going to show you what that means. The way you tend to start is you just write the number at the top. So I just write the number at the top, so the number that they say asked to prime factorize, 42. Write the number, and then you split the number into two factors. Don't split it into three factors. Split it into two factors. It can be any two factors, but I tend not to, don't split it into 1 and 42. Split it into something else, like you could split it into 2 and 21, or you can split it into 6 and 7, etc., etc. So, like there's other ones too. So 42, write the number and then split it into two factors. So in my example, I split. Sorry, someone's just knocking on the door. Okay, so in my example, I split the number 42 into 6 and 7. But I could have split it into 2 and 21, no problem. Just don't split it into 1 and 42. Like, don't split into 1 and the number itself. And so on. And only split it into two factors. Don't split it into more than two factors. It has to be 2 exactly. Notice that if one of them is prime, so if one of the numbers that I've split it into is prime, I circle it to say that the branch has ended, because you're building branches when you build factor trees. So that's why they're called factor trees, because they have branches. So as soon as you get a prime number, you circle it to say that that branch has ended. Whereas 6 is not prime, 6 can be split into two factors. So again, just like you split 42 into two factors that are not one in itself, split 6 into two factors that are not one in itself. So 6 could only be split into 2 and 3. So 2 and 3 are prime numbers, so keep splitting, I'm just going to do that. Keep splitting those numbers into two factors until you have only prime factors at the bottom of the branches. So you stop when you hit the primes. So 7 was prime, so we stop there. 3 is prime, so we stop there, and 2 is prime. We don't split them into 1 and 7. That's like a waste of time, kind of. So once you get your nice prime number, so remember 2 is the first prime number. A prime number has exactly two factors only. So 1 is not a prime number because it has only one factor. Just reminding you of that. So circle those because we're done. And so that is our lovely little factor tree. A common boo-boo is sometimes people just forget the fact that these two numbers must multiply to give that number. Sometimes a common mistake is someone might put 21 and 21 because thinking that 21 plus 21 adds to give that. But instead it should have been 2 and 21. Because 2 times 21 equals 42. 2 times 3 equals 6. So don't by mistake put two numbers that add to give that. It has to be two numbers that multiply. Another way of thinking of it is these two things have to be factors of that number. And the factor pairs, as in those two pair up to multiply to give that. Those two pair up to multiply to give that. So that's an important thing to remember. And as I said, I tend to circle the prime numbers at the bottom of the branches to remind myself that I've finished the branch then. So that was fun. So once you've done that, sometimes if you're asked to prime factorize, you do the factor tree in order to find out the answer to the prime factorization. And what you do is to prime factorize, you just write it out as the product of prime numbers. So product means the result of multiplying. So if you did 2 times 3 times 7, that answer equals 42. So what it means is what prime numbers do you need to multiply together to give that? So the way I would write my answer, just to point out what I'm going on about here, I would finally write as my final answer, I'll scroll down so watermark's not in the way, that 2 times 3 times 7 equals 42. And these prime factors must be in order from smallest to biggest. It's just a rule that's been made that we have to follow. So when you write out the product means the answer from multiplying, the result of multiplying. So the product of 2, 3, and 7 is 42, you would say. whereas the word sum means add, the word difference means subtract, and the word quotient means divide. Product means the result of multiplying. So these all have to be prime numbers. So if they're not prime numbers, that's an issue. So make sure you remember your prime numbers. Go back and revise that if you need to. And you write 40 equals 42, which is the number at the top of the factor tree. So as it says here, write these prime numbers in exponent form. You must start with the smallest base and end with the highest base. So if I happen to have another 2 in my factor tree, I would have written 2 squared times 3 times 7. There'll be some examples of that coming up though, so I'll show you that. So remember your divisibility rules. We've already remembered that if something ends in an even number, it's divisible by 2. If something ends in a 5, it's divisible by 5. If something ends in a 0, it's divisible by 10. Also, if something ends in a 5 or a 0, it's divisible by 5. Remember divisibility rules for 3. If the sum of the digits is a multiple of 3, then it's divisible by 3. For example, 42, add the digits together, 4 plus 2, you get 6, which is a multiple of 3. So that means 42 is divisible by 3. There's some more down here too. So any even number is divisible by 2. No surprises there. If you add all the digits of a number together and the answer is a multiple of 3, then the number is divisible by 3. Hopefully you're familiar with that by now. That's always good to remember. Here's a little example, e.g. 321 you might look at and go, I don't know what that's divisible by. But it is divisible by 3 because 3 plus 2 plus 1, the sum of the digits is 6, and 6 is a multiple of 3, which means that this number is a multiple of 3. If a number ends in 0 or 5, it's divisible by 5. If you double the last digit of a number, hang on, sorry, I'll just have to get rid of this so you can see beyond the silly watermark. Here we go. I'll go back to here. Where are you? So this is an interesting one. This is how you can tell if something's divisible by 7. If you double the last digit of the number, so the last digit of the number, if you double it, and then subtract that answer from the first part of the number, so double this and subtract it from 67. If the answer is 0 or a multiple of 7, then that whole number is a multiple of 7. So, for example, 672, you double the last digit, gives you 4, and then you take the first part of the number and subtract the doubled last digit, so 67 minus 4 equals 63. If this answer is 0 or a multiple of 7, then the number itself is divisible by 7. So there's another neat rule. It's a bit of a weird one to remember though, to be honest, but it's there. It might be helpful when doing these kind of factor trees. Like if you're struggling to see what 2 factors you could split the number into to do a factor tree, these might be useful because this is all non-calculator. And so on. Here's one for multiples of 11. Interesting. If you subtract and add the digits of a number in an alternating pattern, and the answer is 0 or a multiple of 11, the number is divisible by 11. So what do I mean by add and subtract the digits of a number in an alternating pattern? So I'll give you 2 examples. So 1,364. I do 1 minus 3 plus 6 minus 4, for example. 1 minus 3 plus 6 minus 4. See how I'm alternating? I've got the digits in order and I'm alternating subtract, add, subtract, add, subtract, add. So 1 minus 3 is negative 2 using your number line. Negative 2 plus 6 is 4 according to the number line. Have a look in the classroom if you need to. 6 and 4 minus 4 is 0. So if the result of this ends in a 0 or a multiple of 11, then the original number is divisible by 11. Let's do 3729. 3 minus 7 plus 2 minus 9. If there was more numbers, I would be continuing on with like plus minus plus minus. 3 minus 7 is negative 4. Negative 4 plus 2 is negative 2. Negative 2 take away 9 is negative 11. Feel free to go over that again and look at the number line to make sense of it. Negative 11, even though it's negative, it's a multiple of 11. So this one is divisible by 11. Pretty weird, hey? So that might help when we're doing the factor trees on the next page. Use a factor tree to prime factorize 312. So if it's even, I go straight into dividing it by 2. It is a multiple of 3 as well, because 3 plus 1 plus 2 is 6. It's also divisible by 4, it turns out. But I tend to go, if it's divisible by 2, that's a really easy thing to split it into. So 312, I tend to split it into 2, and 2 is prime, so that means the branch is already finished too, so that's why 2 is a good one to split it into. And if you're not sure 2 times what is 312, just do the division on the side, because this is non-calculated, this topic. So 312 divide by 2, so let's see, 2 goes into 3 once with 1 remainder, so I'll put the remainder here. 2 goes into 11 5 times, because 5 times 2 is 10, so 2 goes into 11 5 times with 1 remainder, so I'll put my remainder here. 2 goes into 12 6 times with no remainder, so 2 times 156 is 312. If you've learnt a different way of dividing, that's fine, you just use your way. You're not forced to use my way. You're allowed to use whatever way you were taught in primary school. Okay, so 2's prime, so I circle it, done. All I've got to do is split this one. Now notice it's an even number again. It might be something else as well. It's also a multiple of 3, but I tend to find, again, dividing by 2 is really easy. And 2 is prime, so it means you can circle another branch. It turns out 2 times 78 is 156. If you're not sure, do 156, divide by 2. 2 doesn't go into 1. So I just bring the 1 up here and make it 15 instead. 2 divides into 15 7 times, because that makes 14, with 1 remainder. So 2 goes into 15 7 times with 1 remainder, so I put the remainder here. 2 goes into 16 exactly 8 times with no remainder. So that's why 2 times 78 is 56. Circle the prime number. We've got a prime number, great. If you didn't have a prime number, you would have to split this one as well as that one. 78, it's even again. Go straight to 78 divided by 2, turns out to be 39, because 2 goes into 7 3 times with 1 remainder. 2 goes into 18 9 times. Circle that one. 39, turns out it's a multiple of 3, because 9 plus 3 is 12. So I split it into 3 and 13, because if you're not sure again, 39 divided by 3 is 13. And then don't forget, it says not just do a factor tree. If it just said do a factor tree, you would be done with the factor tree. If it said use a factor tree to prime factorize 312, then you've got to write out the result of the prime factorization. So remember, from smallest to biggest base, 2 times 2 times 2 times 3 times 13. It's got to write out 2 times 2 times 2 times 3 times 13. If one of the factors is being repeated, like 2 times 2 times 2, the way you must write your final answer is you've got to use exponents. So see, there's 3 2's, so it's 2 cubed, because it means not 2 times 3, it means 2 times 2 times 2. So 2 cubed times 3 times 13. See, smallest to biggest base. That's your final answer for the prime factorization. Now feel free to pause and try this one yourself. So I want you to pause and give this one a good old go, and then afterwards you can check your answer with mine. So pause and have a go at doing it yourself now. Don't forget you must put the number at the top to begin with. Okay, off you go. Okay, hopefully you've done that now, and you can check your answer. And you might have done yours in a different order to mine, so long as you've got the same final answer. So long as your final answer looks like this. That's the main thing. I'll go through how I did it. So 1092, it's even, so I split into 2 and 546, and I did my division here to see that 2 times 546 equals that. Circled my prime. 546, even again. So I did 2 times 273, and I worked out 273 from dividing over here. 273, it's not even, but it is a multiple of 3, because 2 plus 7 is 9, 9 plus 3 is 12. And so 273 divided by 3, I got 91, so 3 times 91. 91, it's not a prime number. If it was a prime number, I would finish and circle it there. But it turns out it's not one of the prime numbers. And it turns out that 91 is divisible by 13 and 7. That's a pretty tough one to realize. But you could also use the divisibility rule from before. Remember, you take the last digit and you double it. So double that, you get 2. And if you take the first part of the number, and which is just one digit in this case, 9, minus that, minus 2, and if it's the answer is 0 or a multiple of 7, it's divisible by 7. So you could use that divisibility rule to realize that 91 is divisible by 7. Then you write it out. I write it out the long way first. 2 times 2 times 3 times 7 times 13. See, I've got to have the smallest base to the biggest base. And then the 2 was repeated. 2 times 2, we write it as 2 squared. Times 3 times 7 times 13 is how you must write your final answer. Okay, excellent.